Hello guys, welcome to Ramta Solutions. Today on your probability, we are looking at arrangement of things taken R at a time. Please do not be shocked or intrigued or I don't know whatever, but do not be confused by this topic. Of course, on your textbook, it says it's arrangement of things taken R at a time. And this is basically what you know, but this lesson is specifically for this. So now let us think of it in this way. In competitions, whichever competition you can think of, let's say one that awards 3 individuals from a certain number of contestants, we have to ask ourselves how many ways can the winners be determined? The winners meaning being the top 3, right? We ask ourselves how many ways can the top 3 be determined? Because every one of the contestants could be a winner, right? Every one of the contestants could be a winner, all right? So now this topic is basically looking at that. Now let us try to look at it in this way. Let's say we have 2 people, we have to choose 2 people from a group of 4. How would this look like? For example, we want top 2 from a group of 4, right? So this is what you are doing in counting principle, where you said event number 1, you are choosing from a certain number of people. Event number 2, you're choosing from a certain number of people, 3, and so on, right? And this we were able to simplify it using factorial notation. So now let us look at it in this way. I'm going to do a manual calculation. So let us say since we have a group of 4 people, let us say we have those individuals are okay, let me change the color. Those individuals are A, B, C, D. However, we don't want A, B, C, D. However, 2 of them must be chosen, all right? So what we will have AB, we can also have AC, we can also have AD. Again, we can have, I'm not sure, but we will see. We can have BA, we can have BC, we can have BD, right? Again, we can have CA, we can have CB, we can have CD. Lastly, we can have DA, we can have DB, we can have DC, right? We can have DC, okay? So, something that I want you to really look at is this. When you look at AB and BA, they are somehow, related, right? They are somehow related. So what if, let me make it in this way. So what if we want number 1 and 2? Or what if we want top 2? Okay, what if we want top 2? So if we want top 2, this would be correct, right? If we want top 2, this is correct. A could be number 1, B could be number B. In this case, B could be number 1, A number 2, right? So what if we want top 2? When we want top 2, when you look at it, how many ways do we have? We have 3, 6, 9, 12. So we have 12 ways in which we can select top 2 of this group of 4, right? We have 12 ways of selecting top 2 from this group of 4, right? We have 12 ways. So this is where on your calculator you will be talking permutations, okay? But I will show you that later. So now we are saying that if we want top 2, we have 12 ways of getting top 2, right? We have 12 ways of getting top 2. Anyone could be number 1, anyone could be number 2, just like that. And this is what I have shown you. As you can see, there are 4 people, but we are only taking 2, and there are 12 ways. Okay. Now, what you have seen now is this. We're saying that manually we were able to show this, but now I want to simplify this case. So we are saying that we are arranging n number of things. Okay, we are arranging n number of things r at a time. So what do I mean by that? I'm saying, for example, in that example that we come from, we are arranging 4, right? We are arranging 4 objects, meaning 4 people. How many times at a how many at a time? 2 at a time, right? We are arranging 4 individuals 2 at a time. Okay, so mathematically, what we can do, I'm coming back to this. So mathematically, we can represent this using your thingy, your factorial notation. We can say when we want to find number of things, so when we want to find number of things, number of n things taken, let me just put it like that, number of n things taken r at a time, it will be n factorial of objects over, open brackets, even if you don't open it, it's okay, n, but you have to open it, n minus r, close bracket, factorial. What is n? N is the number of objects you have, and r is the objects that you are considering. Okay, so I repeat, n is the total number of objects you have, r is the objects that you consider for your workings. Okay, n is your number of objects that you are considering. So in our example, okay, in our example, the case study, in our example, n was equal to 4, r was equal to 2. Now I want you to look at it. What are you looking at? You're saying, oh, n factorial, let me just do it here, n factorial over n minus r factorial. What is it? So this is 4 factorial over, open bracket, 4 minus 2, close factorial. What is this? 4 factorial over 2 factorial. This is, remember, 4 factorial, it's similar to saying 4 times 3 times, I can leave it at 2 factorial because I see 2 factorial at the denominator, right? Which is 2 factorial. Therefore, 2 factorials are cancelling. Now, what is your answer? Your answer is 4 times 3. In other words, your answer is 12. Right? Your answer is 12. And you got that 12. Right? You got 12. In this example, you got 12 ways that you can get top 2 from 4 people. Right? So this is it. Now, we're going to do some examples. Without any waste of time, let's head there. And I also need to say to you, instead of going this route, you can alternatively say, for the first place, remember, what is this? Remember counting principle. For the first place, you have 4 people to choose from. Okay? For the first place, you have 4 people to choose from. And then for the second, since you have 4 people to choose from for the first, you will take 1. How many are you left with? You are left with 3. Therefore, you will have 4 times 3, which is 12. So you can also use this method. Okay? But I'm going to use this one for now. Might as well show you what your calculator permits, or what you can do with your calculator. Okay? Now they say, how many ways can 7 vacant places be filled by 10 people? So, using that formula, we will say this is n factorial over open bracket n minus r close bracket factorial. What is this? There are 10 people. But we want 7. All right, we want 7. So what is this? This is 10 factorial. So this is 10 factorial over 3 factorial. So please get your answer there. Use your calculator. Tell me what you're getting. I am getting 604,800 ways. So there are 604,800 ways of filling these vacant places. All right, or filling these vacant places. Okay. Now, or you can do this. You can say this is 1, 2, 3, 4, 5, 6, 7. For the first place, there are 10 people. When 1 is chosen, you are left with 9, and then you are left with 8, you are left with 7, you are left with 6, you are left with 5, you are left with 4. All right, so what is this? This is 10 times 9 times 8 times 7 times 6 times 5 times 4, which is, don't like this one, but it's okay. So this is 10 times 9 times 8 times 7 times 6 times 5 times 4. What is it? It is 604,800 ways. Right? Now, again, on your calculator, I want you guys to note your calculator has this function here. Okay, your calculator has this function here. Okay, so on your calculator, you can press how many objects do you have? You have 10 objects. And then how many do you need? You need 7. Tell me what your calculator returns. So these are called permutations. Okay, these are permutations. So your calculator still returns 604,800 ways. This one here, it is not really prescribed. Okay, it is not prescribed, but it's a good thing to know. Okay, but it's a good thing to know. So your calculator will always give you this. Okay, so the P is for permutations. Okay, it's for permutations. Okay, all right. Okay, now let's go see number 2. Going forward, I will choose whichever is convenient for me at that time, but whichever you want to choose, it's okay. Okay, or maybe let me just continue with all of them. You will choose, but remember what I had said. This one, please do not use because it's not yet prescribed. So do not use this one. However, it's good to know. Okay, perfect. Now, example 2, there are 18 learners in a class. How many ways can we select 2 learners in this class to represent them at a school meeting? Sorry, there's an error there, but it's understandable. How many ways can we select 2 learners from this class to represent them at a school meeting? So it's easy. We can use n factorial over open bracket n minus r close factorial, which is how many learners are there? 18 factorial, and then 18 minus, we only want 2. Right, what is this? This is 18 factorial over 16 factorial. I don't have to expand it, but remember, if you would like to expand it, it's okay. This is 18 times 17 times 16. You can end that because you have a denominator 16, and these will cancel. Okay, so get your answer. 18 factorial over 16 factorial. What is it? It is 306 ways. It is 306 ways. Okay, so a number of ways in which we can select 2 learners from the class to represent this class at a school meeting. It's 306 ways. Okay, or you can say this is 18 and this is 17. So what is this? This is 18 times 17, which is, again, 18 times 17, what is it? It is 306 ways. Or maybe when you write in your exam, normally this is how you say 18 times 7, this is 306 ways. All right? Now, the last one that I really don't advise you use, but it's good to know. It's this one here. Okay? The NPR. Okay? It's the NPR. So let's see. So the NPR, it'll be, you have 18 objects, you are permitting 2. So what is your answer? 18 permit 2. Your answer is still 306 ways. Right? Remember, your calculator has that function NPR. How you do it, by the way, in case I didn't explain it, you just begin by typing 18, and then on my Sharp calculator, I have to press a second function and 6, because on top of 6, that's where you get your NPR. Okay? So you start with 18, then second function. If you're using Casio, I think you say shift and some number. You must make sure you find your thing. You find your NPR. So it'll be 18, shift whatever number it is, and then 2, and then equal to. You will get this. Okay? Perfect. These are called permutations. Okay? Perfect. Now going forward, I'm going to drop this. But when I feel like it, I will bring it back. Right. Number 3, a school needs to employ, the English, a school needs to employ 4 teachers out of a potential 20. How many ways can this be done? It's up to you how you do it. Okay? And I can say to you, just so you get used to that formula, we have 20 candidates. Of the 20 candidates, we only need 4. So this is 20 factorial over 16 factorial. What is this? This is, just press your calculator, please. But if you like, press your calculator. But if you like, you can say 20 times 19. 20 times 19 times 18 times 17 times 16 factorial, because the denominator is 16 factorial, and these will cancel. So what's your answer? However, just press this on your calculator, 20 factorial over 16 factorial. What is it? 116,280 ways that they can employ 4 of the 20. Or we can say this is 20. Remember, the first place is 20. The second is 19 to choose from. The third is 18 to choose from. And the fourth is 17 to choose from. Take your calculator. 20 times 19 times 18 times 17. Can you see it here? Here is it as well. Can you see it? Perfect. So this is 116,280 ways. With that formula, it'll be, we have 20 candidates. We are only permitting 4. Let's try it. 20 only permitting 4. What are we getting? 116,280 ways. Can you see that? Yes, I wrote with a different color because I'm not advising you use this, okay? Because I haven't seen it being used in your examination, in your answer sheets, your memos, okay? I haven't seen it. So please, either do this or this. All right? Perfect. But even this one is the perfect way. Okay. Proceeding. Number 4, we have, this is interesting. So we have oranges. Now, oranges, this word oranges is made up of 7 letters. Now they say how many, number A, let's go. Number A, how many 7-letter words can be made if the letters may be repeated? It's a simple thing. This is 7 times, for the first letter, there are 7 letters to choose from. For the second, there's still 7. For the third, there's still 7. For the fourth, 7. For the fifth, 7. For the sixth, 7. For the seventh, 7. Now this is basically 7 to the 6. Okay? This is, 7 to the 7, not 7 to the 6. This is 7 to the 7. Okay? This is 7 to the 7. Okay? This is 7 to the 7. Now, how many words can you make when these words can repeat, when these letters may be repeated? You have 823,543 words that you can make. Okay? That you can make. All right. Number B, they say 7-letter words that can be made if the letters may not be repeated. This is what exactly we've been doing. I'm going to use 3 methods of solving this. So we have 7. Remember, these ones now may not be repeated. So if they may not be repeated, I will say we have 7 to choose from. Remember the formula. And we need to take 7. So this is 7 factorial over 7 minus 7. Okay? And this is 7 factorial over 0 factorial. Okay. 0 factorial, by the way, guys, is 7. Okay. So press your calculator, say 7 factorial over 0 factorial. What is it? It's simply 40 words. Okay? It's simply 50,040 words. Okay? When you're using this formula. Okay? So for those that do not like this formula, go to your fundamental counting principle. What do you say? You like, okay. Or you can say, for the first letter, I have 7 to choose from. For the second, I have 6. For the third, I have 5. Just like that. Right? Because you are choosing 7. Right? Because you're choosing 7. And then you will say 7 times 6 times 5 times 4 times 3 times 2 times 1. Your calculator returns 5,040. So you can make 5,040 words. Now, with my favorite, something I say do not use, you will say 7 permit 7. Tell me what you get. Remember, in case you forgot, this is NPR. When you have n objects, taking them r at a time. Okay? So let's see. What do you get? You get 50, 40. Right? You also get 50, 40 words. Right? Perfect. So you choose whichever you are comfortable with. Remember, this one, you have for the first letter you have 7 to choose from. For the second you have 6. For the third you have 5. For the fourth you have 4. For the fifth you have 3. For the sixth you have 2. For the seventh you have 1. Okay? This is basically what is happening. Okay? Perfect. Now, maybe I should have fixed this. Let me just fix this. They shouldn't be A, B, C, and D. And D. Okay, and D. Okay. Now, number C, 4-letter words that can be made if the letters may be repeated. It's okay. The letters may be repeated, right? The letters may be repeated. So you have 1, 2, 3, 4. Okay? So for the first letter, you have 7 to choose from. For the second, you have 7 to choose from. For the third, you have 7 to choose from. For the fourth, you have 7 to choose from. So 7 times 7 times 7 times 7, right? What is this? This is 7 to the 4. Right? This is 7 to the 4. Right? This is 7 to the 4. Now, what is this? 7 to the 4 is similar to saying 2041 weights. So we can make 2041 weights. When we make 4-letter weights, in the letters may be repeated. Now, we're making 4-letter weights, but the letters may not be repeated. Okay? Let's see. 4-letter weights, but the letters may not be repeated. So this is easy. Number D, it'll be n factorial over open bracket n minus r close factorial. How many letters do we choose from? 7. And how many do we want? 4. What is this? This is 7 factorial over 3 factorial. You can take your calculator and get your answer. 7 factorial over 3 factorial. What is it? It is 840 weights that you can make. Right? Or you can choose this. 1, 2, 3, 4. Remember, they said they may not repeat. For the first, you have 8. For the second, you have 7. For the third, you have 6. For the fourth, you have 5. Right? So, 8 times 7 times 6 times 5. Get your calculator. Oh, I see I made a mistake. I said 8. There were no 8 weights. There were 7 weights. Sorry about that. So it's 7, 6, 5, 4. Thank you. Okay, so this is 7 times, thank you. This is 7 times 6 times 5 times 4. Okay. So 7 times 6 times 5 times 4, it's still 840. Okay, it's still 840 weights. Now for my formula, if you like, for my formula, 7 permit 4. What do you get? You also get 840 weights. Okay, when you use permutations on your calculator directly, you get 840 weights. So this is it, guys. This is how you do, or you get when you have n objects and taking them r at a time. Okay, and taking them r at a time. Okay, so you will get this question a lot. Please make sure that you ace it in your examinations. Okay. So with that being said, it's a wrap and see you next time. So bye-bye.